Good morning, everyone. I am Karthik, Assistant Professor, Mechanical Engineering Department, SNS College of Technology. In last lecture series of mine, I have spoken about iron carbon phase diagram. In this lecture series, I am going to speak an in-depth version of iron carbon phase diagram, or in other ways we can say I am going to particularly stick on to eutectod invariant reaction, where one solid upon cooling gives two different solids of different properties and different parameters, or else we can say the two solids on heating gives a third solid which has different properties from the first two, right? So the first one is eutectod reaction, where it occurs at 0.8% of carbon, and that too from this eutectod reaction you can name the steel as the steel that is formed at that percentage of carbon is known as eutectod steel. As we see the microstructure of this eutectod steel, you can easily say it looks like the fingerprint of a person, okay, where you can see lines like a white line, a black line, white line, black line, which means that the black lines are nothing but Fe3C, which is known as cementate, or otherwise known as iron carbide, which is prominently seen in the right hand side of the iron carbon phase diagram. And the second one, the white color, which is known as ferrite, alpha ferrite, which occurs at the low temperature region. So predominantly you can see these two these two structures forming at the form a microstructure for the eutectod steel. And the next thing is that this eutectod steel, upon forming, it forms 100% perlite, where you can see only ferrite and cementite. But now we are going to see hypoeutectod steel, where the steel formation occurs at prior to the eutectod reaction, or we can say the reactions or the steel that occurs at less than 0.8% of carbon. So the main difference between this eutectod steel and hypoeutectod steel is that you can see an extra alpha is forming, which is known as proeutectod alpha. We can easily say that this proeutectod alpha is formed during the reaction formation, during the reaction, and during the formation of, or we can otherwise say this is formed during the or before the eutectod reaction that is going to actually happen. So here the composition may varies from alpha plus Fe3C plus we can see this proeutectod alpha that predominantly formed. As you cool down from temperature 1000 to somewhere around 400 degrees Celsius, at 1000 point you can take the carbon percentage of 0.7 or 0.6% of weight percentage of carbon. You can see at 930 degrees Celsius you can say that a fully compounded or a fully formed austenite is the only microstructure that is formed at this region. So next thing is that okay, the next one is that austenite is the only thing that is going to form. Okay, when we slowly cool down in the microstructure, you can see grain boundaries between the two grains. So here this proeutectod alpha usually forms at the grain boundaries of those austenites, and upon cooling, this proeutectod alpha is forming a pathway as it grows on, or as it propagates while the cooling is happening. So when we cool below 700 degrees Celsius, you can see this perlite is this perlite is separated, or the perlite grains are separated, or this proeutectod alpha is formed in between the perlite region. So you can say in this microstructure we have perlite and proeutectod alpha. Thank you.